Here we go in the world of product and quotient rules. Pretty sweet stuff. These are basically just rules that we can use to further our differentiation skills. Let's dive into this. So first we're going to start out with something called the product rule. So as I said here, these are just tools to help us derive. You're still finding derivatives, the slopes of tangent lines, equations of tangent lines, where there's horizontal tangent lines, and the like, right? So you're still doing the same thing, it's just a different way to derive when you have, in this case, a product. So think of it this way, if you have a function times a function, the derivative is always going to be the first function, in this case that's f of x, times the derivative, we'll call that g prime, of the second. I call that first d second, plus second function times the derivative of the first. So again, I'll say that out loud, that's first d second plus second d first. Kind of rolls, first d second plus second d first. Or some other books do it with u times v, where they're both functions of x. That would be first times the derivative of the second. So some people write that as v prime plus the second times the derivative of the first. First d second plus second d first. That could also be written this way, just in case you see it like this, u dv dx plus v du dx. Again, first d second plus second d first. Where does that come from? I'm glad you asked. So it comes from the limit definition of the derivative. Literally plugging in u times v, or f of x times g of x, into the difference quotient and solving it out with some crazy manipulations, and you'll get this. I'm not going to do that for you, right? It's not necessary at all, not even for AB or BC calc. Use the product rule to find f prime of x. So why are we using the product rule? We use the product rule when you have a product. With that said, you use it when the product is not simplifiable easily. So I'm using it here because I want to show you how it works, but in actuality, I would probably do it without the product rule, which I'll show you second. So we do first function, call that u if you want, or f, and then v, first d second. So first is x squared minus 5, d second, or the derivative of the second. That's 4x cubed plus 2x, that would be 12x squared plus 2. So I'm no longer going to go over how to find the derivative of polynomials. If you need help with that, go back to section 2.3 and re-rock those lessons. Plus second, so that would be this, just a lot of copying here. D first times the derivative of that, which is just 2x. And you could simplify it out. I don't know if your teacher will want you to. I'm going to leave it here for now. Maybe in the exercise I'll simplify it down. I just want to go over the process. If you have to do out more algebra, you'll multiply it out, combine all the terms, and we're good. For now, again, I'm going to leave it here. So first d second plus second d first. When you're doing these problems, it's important that you just kind of keep in mind where you are in the process. So when you do first, you're just copying. D second, your mind should hyper-focus on this. Derivative is what you're thinking. Once you're clear out of there, then you back out and say, where am I in the whole process? Oh yeah, plus second, d first, and then you hyper-focus on taking the derivative of the first. It's kind of like your brain's going in and out of focusing on a big picture and then on a part of the picture. So what would happen if we did it without the product rule? Okay, so what that means is we could have multiplied everything out with foiling. X squared times 4x cubed is 4x to the 5th power, foiling. X squared times 2x is plus 2x cubed. Minus 5 times 4x cubed is minus 20x cubed. And then minus 5 times 2x is minus 10x. So we haven't taken a derivative, we've just foiled first. So when we go to take a derivative, we take the derivative of each of these terms. So that becomes 20x squared. This becomes 6x squared. Ooh, not 20x squared, my word. Whew, where did I get that number from? 20x to the 4th, of course, duh, plus 6x squared minus 20x. I guess I could have combined those first. So that's going to be minus, let's see, 60x squared minus 10. And then we can combine like terms. 20x to the 4th minus 54x squared minus 10. So that's doing it without using the product rule. Either way is fine. I'm going to go over later on in this lesson what I call the unnecessaries. I think that I would probably FOIL this one out. I think it's a little quicker, personally. Now, with that said, let's simplify this to show that this derivative, the way we found this derivative, though it's different in process, will still get us to the same answer. So I FOIL, and I get 24x to the 4th, 2x squared, minus 60x squared. And then that's minus 10 on the outside there. Here I get plus 8x to the fourth, right there. So we've got that 8x to the fourth, and then we've got 4x squared. And you know what? I'm noticing that we made a little error. I made a little error there in that 24. That 24 should be 12, right? 12x to the fourth. All right, anyway, so we're back here with 4x squared. Now we're going to combine like terms. So 12x to the fourth and 8x to the fourth is 20x to the fourth. 2x squared minus 60x squared is minus 58x squared, plus 4 is minus 54x squared. And then we have the minus 10 left. So it ends up being exactly equal. Personally, again, I prefer doing it this way. Product rule is great when you cannot simplify a product. More on that one in a little bit in the exercises. Okay. Actually, you know what? Let's do it before the exercise. Let's do it here. Find the slope of the tangent line to g of x at x equals pi over 2. So here's the thing. You're still finding the slope of a tangent line, which means we need the derivative, right? We need g prime, and we want to plug in pi over 2. That's the overall plan. So write that out, and then all we have to do is find the pieces that we need. So we need g prime of x. Well, notice here that we cannot simplify this product. 3x squared times sine x is what it is. So I've got my first function times my second function. So call that f, or u and v if that helps, u and v. So we'll do first d second. First is 3x squared. The derivative of sine is cosine. Plus the second is sine x times the derivative of the first is 6x. And again, what I'm doing here is I'm saying first d second, focus in on this, plus second, copy it, d first. So when I'm going the d first and the d seconds, I'm focusing on those derivatives. And after that, I'm saying, did I do first d second plus second d first? Looking at the big picture and the small picture. All right, so this is our derivative. That's what we just found. We want the slope of the tangent line, so we're going to have to plug pi over 2 into this thing. Now, personally, there's no reason to simplify it at this point because we're going to be plugging numbers in. So g prime of pi over 2 is 3 times pi over 2 squared times the cosine of pi over 2. Again, like before, when you plug in the x value into your slope giving function, you'll get the slope. Plus sine of pi over 2 times 6 times pi over 2. Now, if this is an A, B, or BC free response problem, you can leave your answer like that. That's considered numerical, even with it in the trig function, believe it or not. And I know that because I once called up the organization that makes those tests and asked them. I really did. Actually, I emailed them. They were very nice. Cosine of pi over 2 is 0. So 0 times that is 0. All right, that goes to 0. Sine of pi over 2 is 1. 6 times pi over 2 simplifies to 3 pi. And that is 3 pi. So that's the slope of our tangent line at x equals pi over 2 to that. Same idea, same exercise as what we've done before. Different way to find the derivative. We must use the product rule here. You may not take the derivative of this and the derivative of that and just smash them together. You have to use the product rule here. All right. With that said, I'll see you in another video for the quotient rule. But for now, enjoy this product rule and all of its glory.